Yes, now in last video I have done what is A union B. I just revise it. A union B, I told X where X is an element of A or X is an element of B. A union B is X where X belongs to A. So A union B, we have done this condition. Now one more thing we can write here. If X is belonging to A union B, if X is a member of A union B, then one more thing you should know that X is an element of A or X is an element of B. This way also you should know how to write it. X is an element of A union B means either X is an element of A or X is an element of B. Now, one more thing note here, A union B, I told this. This was A union B. If I say some element does not belongs to A union B, means it is not here. If X is not a member of A union B, means it will be somewhere outside. That means that element can never be in A nor be in B. So whenever we say X is not an element of A union B, we should say X is not an element of A and it is not an element of B, because it should not be in A, not in B. So or will not come, it will come as AND. So in A union B, this thing also you should remember. So A union B we have completed. A union B, I told you, that is the collection of those elements which are either in A or in B or in both. And if it is not in A and A union B, then it should be outside, means it cannot be a member of A and cannot be a member of B. So neither in A nor in B, then it will not be an element of A union B. So that you should keep in mind. Now coming on second part, intersection of sets. In intersection of sets, if we have two sets A and B, non-empty set I am taking. Non-empty means they should not be 5, should have certain elements, and intersection will be denoted by this. So A intersection B. What this says? It says X where X is an element of A and it is an element of B. That means in A intersection B, we should take what is intersection means the common among A and B. For example, if I say one set, we have already done 1, 2, 3. B set is 2, 5. Then A intersection B is clearly 2. Common element will be only 2. So A intersection B is only 2. So A is this, B is this, then A intersection B is 2. So here if I say you make the Venn diagram, this is A, this is B. I want first element if I take, it will be 1 here, 3 here, 2 is here and 5 is here. And if I say A intersection B means I need a common among A and B, and that common is only this much. So whenever I say intersection, A intersection B, when I say only the common portion among A and B will be taken in consideration. So whenever they say you make the Venn diagram of A intersection B means I should consider this as this part. So this is A intersection B. Clear? So Venn diagram of A and B, A intersection B will be this one. Now in this also certain cases arises. What that cases will be? First time if I take A is a subset of B. And if I say you make the Venn diagram, A is a subset of B means A will be smaller set, B will be bigger set, and then this will be the universe. So A set is here, B set is here, A subset of B, then the diagram goes this. And now if I say you draw A intersection B, common among A and B, what is common? Only A. So I should say this answer will be A. Same way if I say B is a subset of A, then In this case, which will be smaller? B is smaller, so B goes here, A goes out here. And if I say what is A intersection B, A intersection B, this time we have only B. So result come out to be B. So A intersection B is simply A intersection B is simply B. If B is a subset of A, then A intersection B you should be, keep in mind B. Now again keep in mind here, whenever intersection, this time the smaller set will be the answer. A is a subset of B. A is smaller, so in intersection A will come. In this, B is smaller, so intersection will come as B. So this way you will be having the intersection of two sets. One more thing I'll add here. By the way, if two sets are disjoint, disjoint means A is having 1, 2, 3. B set is having A and B. And if I say you make the Venn diagram and show what is A intersection B. So when this condition comes, one thing is clear, nothing is common among them. So A will be this and B will be this. Here the elements will be 1, 2, 3. Here the elements will be A and B. Is something common? A intersection B. Nothing is common. Nothing is common means we will be having empty set, or we should say result is simply 5. So A intersection B, whenever the disjoint sets are there, then the diagram says A intersection B is pi. So in short question they can ask, if A and B are two disjoint sets, what is A intersection B? We should say intersection B is pi. And one more thing they can ask, what is A union B this time? If I say you write down what is A union B, A union B will be this time 1, 2, 3, A and B. That means when you draw A union B, then you should draw total. Whenever A intersection B, nothing to be shaded. But when you have union, then this is A, this is B. Here the elements are 1, 2, 3, A, B, and the shade will be done this way. So this is A union B shading. If A intersection B shading will be nothing there, so we will say it will be simply 5. So this is the intersection of two sets. So whenever we think about intersection, I told you when they are joint set, how we are going to have a Venn diagram. If A is a subset of B, what is the diagram? If B is a subset of A, what is the diagram? And if they are disjoint set, what will be the diagram? So every diagram I made clear by taking cases of A union B and A intersection. Now we are coming on next operation, that is complement of a set. Complement of a set. And when you start complement of a set, in that first thing which we should remember is universal set. I told you universal set will be denoted by a rectangle. Now what is universal set? Universal set is nothing but a set which contain all the given sets in the question. For example, A set is given 1, 2, 3. B set is given as 2 and 5. C set is given as 2, 6 and 8. Then D set is having 7 and 8. Now if I say you write down the universal of it, and universal will be denoted by this symbol chi, mu, this symbol or this symbol. This is chi, this will be mu, and this set can be 1, 2, 3, 5, 6, 8, 7 and 8. This can be universal because if you take this, it contains all these elements. If something extra you write, there is no problem. This is again a universal set because this also contains all these. So whenever universal set, and this universal set will be always given by a rectangle, that you should keep in mind. Now coming on this part, complement of a set. In complement of a set, if I say Universal is given as 1, 2, 3, and 4. And set A is given as 2 and 4. Complement of a set will be denoted by AC or A dash. This is called complement of set A. And what this will be? X, where X is not an element of A, okay, but X must be element of universal. Or I should say X where X is not an element of A but universal, means from the universal you should remove that set A. For example, if I'll take this universal set has 1, 2, 3, 4, A set is here, A set is 2, 4, so 1 and 3 will come here. This is our universal, this is set A. If I say A complement means except A, whatever left in universal, that will be called as complement of set. So what is the complement here? The complement will be 1, 3. So complement of a set means that element we should take which are in A, not in A, but they are in universal. Those elements which are in universal but not in A. You can write this way also. It's better you write this way. X is an element of universal, but X should not be an element of A. Those elements of universal which are not in A will be called as A complement. And whenever I say you make the Venn diagram of it. Now if I say Venn diagram of it, universal will be this part we should consider because A should be removed from it. So A complement when I take, it will be that portion which is removed by A, or we'll say A when removed from the universal we get A complement. So if it is A and this is universal, and if I say you plot A complement, that means from universal I remove A, then whatever the portion of universal except A will be A complement. So this will be the A complement we have. I told you universal set. Universal set is a set which contain all the sets given, or the biggest set which contain all the sets in the question. So keep in mind this will be the universal set, and A complement depend totally on universal. From that universal, if you subtract that set or you remove those elements which are in A, we will be getting the complement of set. So this is the third operation we have. Next time we'll take more operations and more diagrams. That will continue next time.